Right. So hi, everyone. Thank you all so much for joining us today at our second annual Fighting Irish Science Olympiad Invitational here at the University of Notre Dame. My name is Sissy Chen.
And my name's Stephen Heritage, and we are co-presidents of Fighting Irish Science Olympiad, and we are so excited and happy that everyone is able to come out here today.
Yeah, so a few years ago, Stephen and I were both sitting in your shoes, out in the audience of one of these award ceremonies. We both competed on our respective high school Science Olympiad teams. And we spent late nights finishing builds and accidentally super gluing our fingers closed, or trying to squeeze in every last drop of information in size 5 font on an 8x11 printer sheet of paper. So I have to say, Science Olympiad, was probably one of my favorite memories throughout high school, and I still am really close with a lot of my team today.
Now standing here, we're very thankful that we were able, with the support of everybody else who helped make this possible, to run this invitational for all of you.
Yeah, and so before we start announcing awards, we would like to thank a few people that we really could not have done this without. First, our Fighting Irish Science Olympiad board, consisting of Ian Show, Nikhil Vijay, Alexander Sterling, and Megan O'Keefe for their consistent support throughout the year to make this event possible. We would also like to thank Jin and Andrew Kim, who were last year's president and vice president, for their guidance and help to make this year's invitational also possible.
We also need to thank all the professors and staff here at the university, because without them, this event wouldn't have been able to happen at all. And they served as invaluable supervisors and just made sure that we were able to do this today. We also like to thank all of our sponsors for their financial support: the College of Science, the College of Engineering, the Glenn Family Honors Program, the Department of Chemistry and Biochemistry, the ACMS Department, Biology Department, the Physics and Astronomy Department, as well as VWR, which is part of Invitational.
All right, so last but not least, we would like to thank Professor Susan Del Valle, who's sitting right there. She's a faculty advisor for Fighting Irish Science Olympiad, and her pivotal support and encouragement throughout this entire year, and all of last year too. And we really, truly could not have done it without her. And we are forever grateful for her contributions to our mission to giving back to our community through STEM outreach. So let's give a round of applause for Professor Del Valle.
All right. Now we are going to play a short video which showcase just some of the cool things that are going on in Notre Dame and some of the amazing things people here are doing.
Growing up, I could do everything anyone else could. Then, when I was 14, I went from being completely normal to not being able to walk without passing out. I was in and out of the hospital for about a year. Finally, the doctors discovered that I have a rare circulation disorder called POTS, which stands for postural orthostatic tachycardia syndrome. My internal thermostat is broken. Even though I couldn't have a normal life, I could still be successful in my own way.
As a PhD student at the University of Notre Dame, Nina Kickle-Corey made a scientific breakthrough. She discovered a new cell in the heart called cardiac nexus glia, which maintains the type of heart rate that is typically seen in POTS patients.
Found that if you remove these cells in the heart, it can actually change heart rate and rhythm.
Here at Notre Dame, we encourage graduate students to choose research that can change the world. Nina's work has every potential to do that.
This discovery could actually be the first step in understanding POTS in patients like myself.
It's amazing to watch Nina work because she doesn't let POTS slow her down. And the days that it's a little bit harder, that's where I step in.
During COVID, I've been in the at-risk group, and so I could not have succeeded without the help of my lab mates. I definitely will. I'll see you later, Lauren. Being in the Smith lab at Notre Dame has been life-changing. They say your friends are there to pick you up when you fall down. Well, they've literally been there to pick me up when I fall down in lab.
The University of Notre Dame asked, what would you fight for?
Fighting for research that matters.
We are the Fighting Irish.
All right, so up next, we would like to introduce our keynote speaker, Dr. Santiago Schnell, who is the William K. Warren Foundation Dean of the College of Science and Professor of Mathematical and Quantitative Biology. Please welcome Dean Schnell.
Thank you. Now it's on. So thank you. So as you can see, I roll my R's with style. So I grew up in Caracas, Venezuela, so which is the northern country in the South American continent. So but my name, so it's a combination of an Spanish and a German name. So my mother is a Spaniard and my father is German, and both they emigrated to Venezuela many, many years ago. So I grew up in there. So, and I, early on in my career, I decided to become a scientist. So, but I wanted to be a medical scientist. So I went through my medical career. So first I did my high school, and in Venezuela, you can do something that in many other countries you can do, which you go straight from high school into medical school. So I went into the medical school, and then suddenly when I started to see patients, so you do the clinical work, I discovered that I couldn't touch people. And I couldn't touch people because I'm obsessive compulsive. So I think that people are going to get me sick. So at the time I used to pour a lot of alcohol in my hands because there wasn't any Purell around. And then the residence chief of the clinic told me, you should do something different with your life, because if you cannot touch people, you cannot be a physician. And I think he was right. So I ended up then finishing my degree without the clinical practice. And I went into a discipline where you combine mathematical modeling with medicine and biology. So in these days, that's called theoretical and mathematical biology. So theoretical and mathematical biologists, they have done really great things for all of us. For example, one historical figure that everyone should recognize is Charles Darwin. So by just making observations of nature, he discovered the theory of evolution. So then you have two other theoretical and mathematical biologists. So you have Francis Crick and James Watson. So they discovered DNA. By just seeing what other experimenters were doing, they reconstruct the image of what our genetic code should look like three-dimensionally into a physical structure that we will be able to manipulate and study. So scientists, what we tend to do is making those discoveries, and we make a huge impact in society in multiple ways. One that should be obvious for all of us is that we read textbooks, like the ones that you're reading in high school and the ones that we teach in the university, that have the knowledge of scientists have been able to transform society. But society is transformed by scientists in many other ways. So if you go to your history books, scientists have played a fundamental role in one way. So do you probably recollect how the historical eras are divided? So they're divided by materials. We talk about the Stone Age. We talk about the Bronze Age. We talk then about the Iron Age. And these days we're talking about the Silicon Age. Who discovered those materials? Scientists and engineers. So we are rewriting history and the way people live by the chemical processes that we are creating into the laboratories to make new materials. So I know that you feel that scientists might not have an impact, that you might not want to pursue probably a career in science. Why? They call us nerds. But nerds are really, really cool because you can create the new material that you don't know which one is going to be, but it might become part of the history books. Or you might become somebody who follows the footsteps of Darwin and Francis and Crick and then you might make into the history textbooks by creating a new piece of knowledge, by doing mathematical and theoretical biology that would transform people's life. Or you can do like many of our students here at Notre Dame, you can study a rare disease. So when you open the textbooks in science, particularly in medicine, you find that the classification has 10,000 diseases. 3 of those are the diseases that we tend to live a relatively healthy life with them. But then you have the 7,000 that tend to be, most of them, fatal. And very few universities in the world that are studying those diseases. Notre Dame is one of those. So if you decide, for example, to come here and study and do research in the biomedical sciences, one area that you could work on, that is one of our strengths, is rare diseases. But we have other strengths as well. For example, the University of Notre Dame play a very important role in the history of nuclear physics and energy. When the Manhattan Project was established, one of the few universities that already have an expertise in the area was Notre Dame. And we pulled scientists from Notre Dame to go into Los Alamos National Laboratory, where is nowadays Los Alamos National Laboratory, to help creating nuclear energy and the nuclear bomb. So, which is, maybe it's not, doesn't sound well, but we make an influence into the lives of people in different ways. The other thing that, for example, very few people actually know, in Notre Dame, there was a conference in the 1930s where there was coined the word galaxy in the way we understand it these days. There are these conglomerates of stars and planets that are all together. So Notre Dame science has been playing for many years important roles. So in the College of Science, we have an area that is called vector biology. So, and it's not the vectors in mathematics. So vector biology are the animals, the bacteria, or the insects that actually can transmit diseases. And as a matter of fact, that's one of our strengths of area as well, because the 2 members of the National Academy that we have in the College of Science, they're in that field as well. So that's another area where you can make an impact. We have a fantastic math department that they have done exceptional contributions in other areas as well. For example, logic, many things that we know about logic, they have been discovered here at Notre Dame. So if you decide to pursue a career, so the options of coming to this university, they're really great. And I can tell you one thing that is very important for us, education. So the University of Notre Dame was established by the Congregation of the Holy Cross. And the founder of that congregation, he had a motto that is a motto that drives every single faculty member at Notre Dame, which is like our mission statement, even though it's not publicly published, that education is a work of resurrection. So this is a Catholic university. Many members of our faculty, they're not Catholics, and many of you might not be. But that statement is incredibly powerful. When you come to the University of Notre Dame, we make an investment, every single faculty member, to make sure that you become a better version of yourself. So that's what that mission statement means. So we want to make sure that when you come to the University of Notre Dame, we are going to raise you from the ashes, and the ashes are your ashes, and make you a better version of yourself so that you can make a higher impact into society and you can become a fighting Irish. So that's my brief speech that I have for you. So I hope you have enjoyed the visit to the University of Notre Dame. But, if you want to have, we can have an open section just of a few minutes. So we have here 3 scientists. We're 3 full-time scientists at the University of Notre Dame. So if you're curious about what is the life of a full-time scientist, this annual opportunity that you can find out. So we are scientists and not only are teaching in the classroom, but as well we're working on our laboratory. So if you want to learn what you do in the everyday of a scientist life, take this opportunity and ask any questions that you might have. Okay, don't be shy. So bring me the questions. I want to hear them. So. Any questions that you might have for a scientist? So about the life of a scientist, or what a scientist does for a living. Shoot. Well, it depends. So I'm a workaholic. So I love to work. And what happens as a scientist? So you have probably heard about the eureka moment. So scientists, regardless of where you are always something machinated in your brains to solve the problems that you have in the laboratory. Sometimes you wake up in the morning and you have the solution. And that is when you rush, even without taking a shower, and it not be a good idea to do that, and go straight to the laboratory to solve it. But we work hard, but at the same time, we do it because it's a vocation. So we feel that it's the love of the work. Yes. It's an excellent question. So scientists, by the way, so scientists are well paid. So if people are afraid that if you go to science, you're going to be starving to death, there's a misconception. So scientists were paid if you work for a university by the university. And depending on the university where you are and the work you do, you can be paid by 10 months and then or 12 months of salary. So the 10 months of salary is sufficient to live, even if you don't receive the 2 extra months of salary that you can get from the federal government to do research. So if you work for a research facility that is owned by the government, a national laboratory, they pay you from there. If you work for a private institute, the private institutes as well, they pay you from their funding, but as well you can get salary from the grants. And sometimes you do a combination of both. But scientists, most of them belong to the upper middle class, so they can make a good living. So if you're afraid of going to the career, you're not going to start to that. There's another question there. Yes. Oh, yes. So, well, I say that I'm a theoretical mathematical biologist. So let's see where my colleagues are.
So I am a theoretical chemist, which means I do computer and mathematical modeling of chemical reactions.
And I'm what they call a teaching professor. So that's what I do full time. But I did my research first on DNA and RNA and proteins. I did a lot of research on that. And then I worked in publishing for about 10 years, scientific publishing. And then I went on to teaching. So I've kind of had an unusual route to get to the teaching position, which I'm very happy in, boss. but there's lots of different things that you can do as a scientist. And you'd be surprised that, if you find that you love science, but, maybe this isn't really like in the lab. I liked the lab, but I wanted something different, and it wasn't too hard to change. So it's a very flexible field. It's much more flexible than you would think.
So let me give you an idea about the flexibility in science. So I have many people who have graduated from my laboratory, so they did their PhDs with me, and there's something that is called a postdoctoral position. So individuals who have left my group, and remember, I'm a theoretical and a mathematical biologist. So I have members of my group who work for Google X. So they have taken their expertise that they have learned working with me to work for Google. I have others that actually work for banking. They're investment bankers that with their computers using the skills of modeling that they learn to actually do investment. I have individuals who have become full-time editors. They are editors that work for journals or publishers publishing science books. So I have others that actually have gone full-time into medicine. So after doing the PhD with me, they are physicians. And there are others who have gone into biotechnology who have established their own companies. And I have one that recently went into consulting and VC, which is venture capital. So the science degree gives you the flexibility of, following multiple pursuits. And the fact that you have worked in one field, it doesn't mean that you have to continue working the rest of your career in that one. So for example, I started in medicine and I end up working on mathematics. So there's a lot of flexibility of what you can do with your academic credentials and then go into the job market. Any more questions? Well, I'm now like the school principal of the College of Science. So I spend a lot of time doing administration, fundraising, fighting with the politicians, and so on. But when I was a full-time scientist, So, well, I would do primary three things. So all professors, we do three things. So we do research, and that represents a significant component of our careers if we're in a top-ranked research institution like Notre. So we may spend like 60% of our time doing full-time research. And that means, you wake up every day with a problem and you're machinating about the problem. And then you are supervising undergraduate students, graduate students, and postdoctoral fellows in your laboratory who are scientists working with you. And it's a combination of doing experiments, presenting those experiments to your colleagues to see if you have committed a mistake, and then publish them. And in addition to that, we need to get financial support from the government to do research. So, and then the rest of the time, like the 40% of our time goes into teaching and providing services for the university. Kinds of services. We organize science Olympiads. We do teaching. We do admissions for graduate school. We just help to maintain the facilities by, hiring the right people who can maintain them, making sure that they follow the protocols that are necessary for having laboratories that work for us. So that's the kind of daily work for a scientist. If you work for a research institute, you wouldn't be doing the teaching and very little service. You will be like 80% or 90% of your time doing research. So.
Often would you say research online versus like data in the lab?
Well, you research online. So scientists, we do something which is very funny. So scientists, we navigate to spaces. When you research online, so we're navigating the space of knowledge. We want to figure out what is information that is available in there. But when we work in our research group or by ourselves in the laboratory, we're navigating the space that I call the space of ignorance. We have no idea what's going on. So and we're asking the right questions to figure out if we can learn something about the problem we're working on. And I would say that, we spend most of our time in the space of the ignorance, figuring out what's happening with the data that we're generating in our laboratories. So I think that's the life of a scientist. You have no idea what's happening and you're failing so many times. You have no idea how much you're going to be failing. So you fail all the day. So you grow a very thick skin, and failure for us, we're not afraid of failure. So these days, to scientists, once you finish your PhD, you are not scared of almost anything. And it's because you have failed so much that you have lost all your shyness about failing. So in fact, we're very proud of failing. So I can tell you how many failures I have had every day. And I have the badges and I carry them every day with pride. Then on the back. So can you speak a bit louder than I could? Yeah. Well, Dan, so did you hear the question? So it's a process of, let me go there so that everyone can hear.
I was just wondering, what's it like in the getting your PhD, like the process of getting the PhD? Like, are there many like major papers or like projects that make up getting this like really hard degree? Because I wanted to go into the medicine field.
So getting a PhD was actually a lot of fun. The first 2 years was coursework and teaching, TAing in a lab. And then I got thrown into a lab where like Santiago said, I had no idea what we were going to discover. In fact, there were things that the most important thing that happens during when you do research is you come in and you start an experiment or you start a computer simulation and you get a result and you look at it and you're like, that's weird. That's the most important moment of doing science. It's not this eureka. It's like, that's weird. Why is it doing that? It's got to be wrong. And that's sort of this really weirdly uncomfortable point where the thing you thought was right has been shown to you by the world that it's not right. And so now you got to figure out, why is it not right? So imagine 4 years of that. And it's actually a lot of fun, because once you figure out why it's doing what it's doing, then you've discovered something and you write a paper about it and tell everybody else you can find, and they're like, okay, that's fine. You have to be very comfortable with expanding something, a piece of knowledge that's really, really specialized. But you then become the world's expert in that particular thing. So I had a great time doing my PhD.
A PhD it's not an easy degree to get. You have to spend a lot of time working hard on your research. Sometimes you're not only the only person in the lab that knows what's going on, maybe you and your PI, but you really are the only person in the world. It's very much like, this is on you. You got to figure it out. And that's okay, because you have all the skills. You've been through all the schooling. You've been through all those coursework, and you're the one with your hands on the materials. So you can really start to play with it once you get comfortable with the fact that this is yours. And I'll echo, it's not an easy place to be, but it's also insanely rewarding when you're just like, I've got something new. It's really fun. I've done it, to run around your lab and tell everybody, oh, look at this, right? Or to go to the person that you're working with on the project who maybe wasn't there at the time, and show them and say, look what I found. Look, what do you think of this? And then you kind of get that back and forth of, what do they think? How do what do you have to support what you think? And it just really takes off from there. But it's true, you got to get through that uncomfortable part. So if you go for a PhD, I don't want you to think it's going to be roses the whole way. There will be hard days, but after the hard days come amazing days that you wouldn't get through most any other experience. That's what I would say. Yeah.
The good thing of it is that you get paid for it. So it's the first degree that you're going to be getting where you don't have to pay anything to the university. You actually get paid to do research. And in my experience, it's very similar to what they explained, but the best way I explain it to people is like, you go to a circus and suddenly you become an acrobat. And what you have to do is walk on the rope. And while you're walking on the rope, so you are always trying to keep on the rope, and sometimes you will fall and you have to come back because the problem is very difficult. And then as you go down, so you are growing, frustrated sometimes. Sometimes you're very excited because you know that you're halfway through, and then you need to start to climb up again. And in the moment you climb up again, you really feel great. And I can tell you in my research group, so they think that I'm completely insane because when I, hit that moment, sometimes I get so excited that I start to scream, go, and I run through the hall, up and down. So they know that I have done something that it took me a lot of work because, I'm running around. So it's that sensation that is pretty unique. So it's a good degree to get, but as well, it's a fantastic career to have, the career of a scientist. So I think we're probably running out of time. But if you have any more questions, so the three of us will be delighted to ask you anything about what is the life of a scientist. And I hope you have enjoyed your visit to Notre Dame. So if you have as well questions about the University of Notre Dame, we'll be delighted to answer those as well. Thank you.
That's the end of this, right?
Yeah, that's the end of this. Here, I'll pick it up while you make the joke.
All right. I know what everyone's here for. Everyone wants the awards. No? Did I hear no? Okay, we can just end this now. No. On a more serious note, as Dean Schnell said, scientists fail all the time. We kind of did that. So as a result of that, if you medal today, you get the very exclusive elementary science Olympiad medals. Shaped like a football. So they are Notre Dame themed. They are Notre Dame themed.
All right, and so when you're coming down, when we announce the words, we'll announce third place, second place, and first place. So you'll receive your medals from these three amazing scientists. So if you get a bronze medal, you'll receive it from Dr. Susan Del Valle. A silver medal, you'll receive it from Dean Dan Gezeltzer, and the gold medal you'll receive from Dean Santiago Schnell. So everyone can walk around from your right to left. So if you're sitting on this side of the audience, we would love for you to kind of wrap around and then receive your medals. Yeah, and also feel free to take photos. I know this is very exciting. So yeah, without further ado, let's get started.
All right. First event, first one alphabetically, anatomy and physiology. In third place, Munster Red. Each person. In second, John Adams B. No, you still got it. And first place, anatomy and physiology, Lake Central on ground. It's fine. You can just go there.
Just want to make sure that they're done receiving their medals. All right, our next event, astronomy. So in third place, we have Munster Red. All right, in second place, we have John Adams B. All right, and in first place, we have Munster White. Okay, that's a good point. Start scheduling.
Dramatics. All right. Next, bridge. In third place, Whiting A. I like Andrew. In second place, Lake Central Andre. And first place in bridge, Northridge Green.
All right, next we have cell biology. So in third place, we have Whiting A. In second place, we have John Adams B. And in first place for cell biology, we have Munster White.
Yeah. Next, Chem Lab. Third place, Munster Red. In second place, North Central. And in first place, Chemistry Lab, we have Munster White.
All right, up next, we have Code Busters. So in third place, we have Munster Red. In second place for Codebusters, we have Northridge Green. And in first place, we have Munster White.
All right. Next, detector building. In third place, Northridge Green. In second place, Munster White. And in first place for detector building, Mount Vernon.
All right, our next event is Disease Detectives. So in third place, we have Northridge Green. In second place, we have Munster Red. And for first place for Disease Detectives, we have Munster White.
All right. Next up, Dynamic Planet. In third place, John Adams B. In second place, Munster White. And first place, Dynamic Planet, Munster Red.
All right, up next, we have Environmental Chemistry. So in third place, we have Northridge Green. In second place, we have Munster Red. And in first place for Environmental Chemistry, we have Munster White.
All right. Next up, experimental design. Third place, Munster White. Second place, Lake Central Andre. And first place in experimental design, Northridge Green.
All right, our next event is flight. So for first place, or for third place for flight, we have Whiting A. In second place, we have Munster Red. In first place, we have Northridge Green.
All right. Next, forensics. Third place, Munster White. Second place, Northridge Green. And first place in forensics, Munster Red.
Right, next, we have forestry. So in third place, we have Sylvania Southview A. Second place, we have John Adams A. In first place for forestry, we have Lake Central.
All right. Well, I'm early. Okay, moving on. Green generation. In third place, Lake Central off tray. In second place, Munster White. And in first place, Green Generation, John Adams A.
All right, next we have It's About Time. So in third place, we have Munster White. All right, and in second place, we have Northridge Green. And in first place for It's About Time, we have Munster Red.
I'll explain. Thank you. Okay, next, remote sensing. Third place, North Central. Oh, well. Second place, Lake Central Andre. And in first place for remote sensing, Munster White.
I'm very All right, our next event is Scrambler. So in third place, we have Northridge Gold. Second place, we have Northridge Green. And in first place for Scrambler, we have Lake Central Orange.
Biggest outlook. That's like a car event where they're trying not to break an egg on a wall. So scrambled egg, yeah. It's an egg fun. All right. Next up, Wi-Fi Lab. In third place, Sylvania Southview A. In second place, John Adams B. And first place in Wi-Fi Lab, Northridge Green.
All right, our next event is Write It, Do It. So in third place, we have Northridge Green. In second place, we have Northmont. And in first place for Write It, Do It, we have East Noble.
Okay, and you thought we forgot about these or that we just can't spell. What next? Rocks and Minerals. In third place, Lake Central Andre. In second place, Munster White. And first place, Rocks and Minerals, Munster Red.
All right, last but not least, we have Trajectory. So,
Oh, Fermi did not get added. You are correct.
oh, just
fix
kidding, not last
I'll
but
fix
not
that.
least.
Keep going.
All right, I'll keep it going. All right. So, Trajectory. In third place, we have East Noble. Right. In second place, we have Lake Central Orange. And in first place for Trajectory, we have Whiting Arrows. We forgot about Fermi. So I'm not sure, but I'll make it. All right, and I'm sorry to keep you all waiting, but we have one more event that is being finished up right now. Fermi. So hopefully we'll be able to get that done as soon as possible, and we'll be able to move on to the overall team awards. So if you guys have, question, yes, go ahead. Wait, I cannot hear you. All right, can everyone quiet down? We have a question. Go ahead. So there is not a college level science Olympiad, like with all of these events. So oftentimes, the Science Olympiad tournament is actually hosted by different universities, around the state. So Notre Dame, this is our second year doing it. I kind of wish that there was a college, Science Olympiad event, but honestly, it's really fun, being able to write the tests and then having all of you come to our university as well.
No, I got it. I got it here. No, I have it here. I have it right here.
Oh, I guess even this almost.
No, I grabbed the wrong one. I grabbed the wrong one. I grabbed the wrong one. Where'd it go?
Right there.
Yeah, no, I grabbed the wrong one. No, we're good.
All right, back to normal programming. We're gonna go.
I swear we had these. I swear we had these. Third place for me, Lake Central Andre. Second place, John Adams A. And first place in Fermi questions, Munster White. All right. That's it.
That's the last one. Now overall.
Yes.
One of us switch it all.
And then say, preface the question, like if your team's called, come down to take a photo. Yeah, you guys are good. Yeah, well, we'll clean it up. Thank you.
Yeah, thank you
Thank
so
you,
much.
Deisha.
All right, so now to the part that you all have been waiting for. Overall team awards. So as we announced, third place, second place, and first place, we would love if, the team, if you want to come down together and take a photo, that would be welcome. So
similar to our ineptitude in making medals, we are also inept in ordering trophies, apparently. So unfortunately, we will not have a trophy for you.
all right, so third place overall, we have Lake Central Andre.
I'll see if you want to come down. Yeah, photo. Yeah. Yeah, go here. Maggie, stand up in the top. Second place, Munster White.
I will say, I make it very. If you guys wanna line up in the front,
Yeah.
we'll have the picture takers up there, so.
Everyone. There right now. Guys, it's a line. I'm trying. All right. Up there. Up there. Up there. Up there. Up there.
There, look at her. She's got the.
Like, sure. Here, if you want to talk, I should say.
Okay. No, I can switch. Sorry, time. All right, now, can we get a drum roll for first place? In first place, we have Notre.